Hello everyone, welcome back to my channel. My name is Anton G. Tolosa. For this day, we will summarize the chapter 5 of the networking one in NetAcad. But before that, we need to read the introduction of this chapter. Chapter 5, Ethernet. The OSI physical layer provide the means to transport the bits that make up a data link layer frame across the network media. Ethernet is now the predominant LAN technology in the world. Ethernet operates in the data link layer and the physical layer. The Internet Protocol standard defines many aspects of network communication, including frame format, frame size, timing, and encoding. So, when messages are sent between hosts on an internet network, the host format the messages into the frame layout that is specified by the standard. Because Ethernet is a comprised and standard at these lower layers, it may best be understood in reference to the OSI model. The OSI model separates the data link layer functionalities of addressing, framing, and accessing the media from the physical layer standard of the media. Ethernet standard define both the layer 2 protocols and the layer 1 technologies. Although Ethernet specifications support different media, bandwidth, and other layer 1 and 2 variation, the basic frame format and address scheme is the same for all varieties of Internet. This chapter examines the characteristic and operation of Ethernet as it has evolved from a shared media contention-based data communication technology to today's high bandwidth full duplex technology. We are done in introduction of this chapter. Then we go to the summary of this chapter. Ethernet is the most widely used LAN technology today. It is a family of networking technology that are defined in the IEEE 802.2 and 802.3 standard. Ethernet standard define both the layer 2 protocols and the layer 1 technology. For the layer 2 protocols, as with the all 802 IEEE standard, Ethernet relies on the two separate sublayer of the data link layer to operate the logical link control or the LLC and the MAC sublayer. At the data link layer, the frame structure is nearly identical for all bandwidth of the Internet. The Internet frame structure adds headers and trailers around the layer 3 PDU to encapsulate the message being sent. There are two styles of Ethernet framing, the IEEE 802.3 Ethernet standard and the DIX Ethernet standard, which is now referred to Ethernet 2. The most significant difference between the two standards is the addition of a start frame delimiter or the SFD and the change of the type field to a LAN field in the 802. Ethernet 2 is the Ethernet frame format used in TCP/IP network as an implementation of the IEEE 802.2/3 standard. The Internet frame provides MAC addressing and error checking. The layer 2 addressing provides by Ethernet support unicast, multicast, and broadcast communication. Ethernet uses the address resolution protocol to determine the MAC addresses of destination and map them against known IP version 4 addresses. Ang haba. Each node on the IP version 4 network has both a MAC address and an IP version 4 address. The IP addresses are used to identify the original source and final destination of the packet. The Ethernet MAC addresses are used to send the packet from one Ethernet NIC to another Ethernet NIC on the same IP network. ARP is used to map a known IP version for addresses to a MAC address, so the packet can be encapsulated in an Ethernet frame with the correct layer 2 address. So ARP relies on certain types of Ethernet broadcast messages and Ethernet unicast messages called ARP requests and ARP replies. The ARP protocol revolves IP version 4 addresses to MAC addresses and maintain a table of mapping. So on most Ethernet networks, end devices are typically connected on a point-to-point basis to a layer 2 full duplex switch. So a layer 2 LAN switch performs switching and filtering based only on the OSI data link layer or the layer 2 MAC address. A layer 2 switch builds a MAC address table that is used to make forwarding decision. Layer 2 switches depend on routers to pass data between independent IP and the subnetwork. So the chapter 5 of this, which is the Ethernet. It is all about the Ethernet. So we all know that Ethernet is a technology that connect wired local area network and enable the device to communicate with each other through protocols, which is the common network language. So here's the video of how the internet works. Okay?
So you have your home network, with your computer, network-connected printer, smart appliances all connected to your router. Have you ever wondered how your computer knows to send your document to your printer, and not your light bulb? Let's take a look. Please note, this video simplifies some concepts for easier understanding. If you need an accurate documentation, please see the description below for links. The internet is comprised of multiple layers, and today we're talking about one of the lowest ones, Ethernet. If you don't know what this means, that's fine, just tag along and it will all become clear. To understand how your local network works, we need to go back in time about 30 years. Back in those days, computing hardware was rather expensive. Instead of the current setup where we plug everything into one router, a much different system was in use. All network-connected hardware had to be linked up to one long coaxial cable. At any given time, only one device could send data over the network, so the system had to be designed around that. When a computer wanted to send data, it first had to shout a special set of bits on the network, which basically equates to "Everybody please be silent, I want to send something." If two devices did this at the same time, they would detect this conflict and wait a random amount of time before trying again. This initial sequence of bits is called a preamble. Once a device has successfully gotten their preamble out, they could then send data over the network. In order to ensure that every device gets a chance to send data, the amount of data they could send was limited. If they wanted to send more data, they would have to split it up into multiple pieces called Ethernet frames and send them one by one. To locate their target, every network device had a unique number called a Media Access Control Address, or MAC for short. MAC prefixes are assigned to hardware vendors, and each network chip or card gets a globally unique address. These MAC addresses were used in Ethernet much like addresses are used on envelopes. After the preamble and a short pause called the start frame delimiter, devices had to send the MAC address of the target computer followed by their own MAC. If they didn't know the destination MAC, or they wanted to send something to every machine on the network, they could use a special broadcast MAC of all Fs. This enabled machines to advertise services such as print availability or file shares to other devices. Regardless of the destination MAC, however, these Ethernet frames may in some cases be sent to all machines on the network. In other words, you cannot rely on the correct MAC address for security. This is true even with high-end data center equipment. Following the MAC addresses, the Ethernet frame must also contain one more field called the ether type. This field is a bit tricky because it can be used for two different purposes. If the number in this field is 1500 or lower, it indicates the total length of the Ethernet frame. If it is 1536 or higher, it indicates the type of data contained within this Ethernet frame. Nowadays, it is typically used to indicate the contents of the frame rather than the length. After all this addressing information, we are now finally able to send some data over the network. On a typical setup, this information is limited to 1500 bytes, which is then followed by a so-called checksum. The checksum verifies that the contents of the frame have not been corrupted in transport. That's it. The frame is now sent, and after 12 bytes of silence, the race for the preambles can begin again and more data can be sent. If we come back to the present, not much has changed. Sure, we have dedicated cables for our devices, and we have smart switches and routers that can communicate with multiple devices at the same time, but the Ethernet protocol itself hasn't changed much. Apart from some carrier-grade networks, we still use the same frame structure for our local communication. If you want to take a look at Ethernet in action, I recommend you install a program called Wireshark, which lets you look at the traffic on your own computer. As you may notice, Ethernet is a local network-only protocol. It doesn't provide us with any means to communicate with devices outside our own environment. That is the task of IP, a protocol that sits on top of Ethernet, which we will discuss in another video. Thank you for watching. If you learned something today, feel free to like, share and subscribe, and I will see you next time.
So, Internet relies on the two separate sublayer of the data link layer to operate. So, it is the logical link control and the MAC address. So, the logical link control or the LLC handles the communication between the upper layer and the lower layer. So, this is the typically between the networking software and the device hardware. Then the MAC, so it is the lower sublayer of the data link layer. So MAC is implemented by hardware, typically in the computer NIC. So here's the video of the logical link controller. So that's all for today and see you in my next video. Bye bye.